Alright class, in this session we are going to continue the topic kinematics which we have discussed in yesterday class. And now in this class we are going to continue the new exercise 2.2 of the same topic kinematics. The question number 1, the question says, diagram shows an x-y graph for a moving particle along a straight line and the equation of movement is x equals to p minus 1 whole square plus 4 for p greater than equals to 0 and lesser than equals to 4. As you can see, there is a graph of displacement time graph and it's a curve. Alright? We need to find out the velocity at p equals to 1 and at p equals to 6. So we need to find out the velocity from your distance time graph. So the equation we have is distance is equals to p minus 1 whole square plus 4, and distance in terms of x we have finally replace x here. Alright, it's x and p graph. We need to find out the velocity. How is it going to find out the velocity from distance? That means we need to apply differentiation here. So before differentiation, if I'm going to expand the bracket, so that will be x equals to p square minus 2p plus 1 plus 4. And if I simplify the equation, I will get x equals to p square minus 2p plus 5. Okay? That is my distance expression. Now we need to find out the velocity, so I'm going to apply differentiation on both sides. So that will be dx over dt equals to, when I derivate this equation here, so t square derivative it's 2t minus 2p derivative it's 2p. Alright, that is my differentiation, or you can say that it is an equation of my velocity. We need to find out the velocity at t equals to 1 and at t equals to 3. So at t equals to 1, velocity equals to 2 times the value of t is 1 minus 2. So velocity is 0. Alright, and if you place the value of t as 3, so velocity equals to 2 times 3 minus 2. 2 3 are 6, 6 minus 2 is 4 meters per second. Alright, so for first part we have two answers, that is 0 and 4 meters per second. Alright, so I hope that is clear to you. You need to write down the solution in your copy. You have a time of 90 seconds, so start. Alright, after that for part B, it says the total distance traveled during the interval from 0 to 4 and hence average speed over this interval. Okay. So we need to find out the distance on the graph, right? The distance the curve covered during the interval from 0 to 4. The equation we have for the distance is equals to p minus 1 whole square plus 4. and when we expand it, we got the expression is t square minus 2t plus 5 as we had done previously. So starting point is 5. So let's say if the particle starts from this point, and from this point to this point the distance it travels it's 1, right? So the distance it travels it's 1 meter, and after that from the point the value of y-axis here it's 4, right? From 4 till the point it's 13. From 4 to 13 the distance traveled is 9 meter. So the total distance traveled by the particle is 9 meter and 10 meter, 1 meter, sorry. So 9 plus 1 equals to 10 meters, that is the total distance traveled. If we have different graph, like say velocity time graph, then the approach will be different to find out the displacement. Alright, but since we have already displacement time graph, we just need the values from the y-axis, it gives the value of distance we have. Alright, and after that it says hence find the average speed. The working formula for average speed we have, it's total distance divided by total time. The total distance traveled by the particle we have find out is 10 meters, and the total time you can see on the x-axis it's 4. So the average speed is 5/2 meters per second. Alright, so I hope that it is clear to you. Now you need to write down the solution in your copy, and we have a time of 60 seconds, so start. Alright, then moving on towards the next question. It's question number 2. It says the displacement x meter of a particle from a fixed point along the line it is traveling is given by x is equals to 6t minus t square. Sketch the displacement time graph with the help of this graph. Find total distance traveled in the first 6 seconds. So we need to start the sketching part, but before that, if I take common t here, so that expression will be 6 minus t. Alright, and now if I start the construction work, so when x is 0, you will get two values of t, that is t equals to 0 and t equals to 6. Right? That means your graph will be plotted between these two curves. So if I draw the curve here, so somehow I will get this shape, right? It's a parabolic shape because the equation is following the pattern of equation of parabola. That's why it is a parabolic curve. Now what is the highest value here? So we had discussed while plotting the quadratic curve that this line will be the highest point which lies at the symmetrical point. Alright, so what is the exactly half number between 0 and 6? So this point will be 3. So we need to find out the value of your distance, which is on the y-axis, and time on the x-axis. Right? So you need to find out the value of distance at t equals to 3. So for first part we have the equation x equals to 6t minus t square, which we had simplified to t 6 minus t, and now the value of t it's 3, so it's 6 minus 3, 6 minus 3, 3 3s are 9. So that means the particle highest point of distance is 9 meters. Now, if you observe closely, so when particle starts from rest and from the high to the highest point, it covers a distance 9 meters. That means that after this highest point to the lowest point, again it will travel the 9 meters. So the total distance particle travel in the first 6 seconds is 18 meters, and that is your first part answer. Alright, so firstly you need to plot the solution for first part, and you have a time of 90 seconds. So start. Alright. For part B, it says find v in terms of t and stretch the velocity time graph. Alright. So you need to find out the expression for velocity in terms of t. You have displacement equals to 6t minus t square, right? In order to find out velocity from the expression of displacement, we need to derivate it. So if you derivate the function dx over dt equals to d over dt of 6t minus t square. Dx over dt leads to velocity equals to d over dt of 6t will be 6 minus 2t. That is your velocity expression in terms of time. So let me draw the curve here, not the curve axis first, and axis will be the same as we have drawn for the displacement distance term, right? So that is my axis, and the values will be same: 0, 3, and 6. The values we have mentioned above. Now we are plotting this velocity time graph. So first I will find out the values of velocity at these 3 points, 0, 3, and 6. So when the value of time is 0, we have velocity equals to 6, right? When the value of time is 3, we have velocity equals to 0. And when the time value is 6, so we have velocity equals to negative 6. Now we see a pattern that first the velocity is positive, then my velocity is 0, and then it is a negative 6. So if I plot the points at 0, my velocity is 6. Let's suppose this point we have 6 here. At 3, my velocity is 0. And at 6, my velocity is negative 6. That is this point. Alright, so I need to extend my curve here. Let's say here. And at t equals to 6, my velocity is negative 6. That is this point. So you got a straight line you need to plot. So that's how your velocity time graph looks like, with a specific case of x equals to 6t minus t square. Alright, so that's how your velocity looks like. And you can observe that at 3, when you have maximum distance, so it is at this point the velocity is 0. Why is it 0? There is a straight logic here. Let's suppose this is a distance time graph from a car, right? So you can observe that when car reaches this point, at this point its velocity will be 0, right? Because it's a maximum point, and after that it will be in a decreasing pattern. That's why velocity is decreasing here. Alright class, let's say that you have a car and its speed at this point is 10, let's suppose, right? We have just assuming it. So when the car is the line curve is increasing, so its speed will be decreasing. It's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 0. And after that its speed will increase, but this direction is a negative direction, right? That's why we have a negative axis for this part. Alright, so I hope that it is clear to you. And first you need to write down the solution in the copy, and you need to draw the graph, this portion as well. And for this part you have a time of 2 minutes, so start. Alright class, now after part B we have a third part, and it says, is the particle accelerating or decelerating? Is it doing so uniformly? Alright. For C part, we have the expression for velocity. We have x6 minus 2t. Alright. If you need to find out the acceleration from the velocity, so you need to derivative. And we are going to do the same. We are going to derivate our velocity expression. The derivative of velocity is acceleration, and the derivative of constant is 0. Derivative of minus 2t is minus 2. So you got your acceleration, which is minus 2 meter per second square. So the minus sign indicates that it's a deceleration, right? So the particle is decelerating, and the acceleration is constant. So we can say that this minus 2 indicates that it is a uniformly deceleration with the value of 2. Alright, so that is your answer. It is very simple. You just derivate the velocity to find out the acceleration. The value of acceleration is constant, that is why we are saying that it is uniformly, and the negative sign indicates that it is a deceleration here. Alright, so write down the solution in your copy, and for the last part you have a time of only 30 seconds because it is quite short part. Alright, so start. After that, moving towards the next question. It's question number 4 from the same exercise 22.2. And now in this question we have a velocity time graph. First we need to read the question carefully. Diagram shows the velocity time graph of a particle moving in a straight line. Describe briefly the motion of the particle. So if a particle is starting from this point, what do you think its motion is? First, you can see that it's a constant velocity, constant speed, and after that you can see that you have a reduction in your speed. Alright, or you can say direction is negative here, like the one we have plotted here. It's the below the x-axis line, it means the direction is negative now. So we can write in this way: particle travels at constant speed from starting position to time t1. Alright, that is for this part. And after that it is decelerating. After t1 it starts deceleration. Between the time is from t3 to t1, between t3 and t1. Alright, so that is the first part answer. And for part B it says, if the particle has returned to its starting point after time t3, what deduction can be made about the regions marked A, B and C? So basically it says that after this point particle come back to its original point. So it means that the distance the particle traveled here and the distance the particle traveled here, it is basically equal, because after this point, until this point, the particle returns to its original position. Alright. So what statement we can make here? We can say that area of A plus area of B equals to area of C. And why we are talking about area? Because in the velocity time graph, distance is basically area under the curve. Alright. So if to find out the distance of A, simply we need to find out the area of this shape. If we find out the distance of B, then we need to find out the area of triangle, and simply for area of C represents the distance traveled in the region C. Alright, so the distance traveled in the first A and B region and the distance traveled in the C region, basically the both are equal, and this is the statement we can make for part B here. Alright, so before moving to any other question, I think it's better if we attempt one example here, because examples are very good for clearing the concept. You can see that the diagram shows the velocity time graph for particle P moving in a straight line, and there are 4 parts. The first one describes very briefly the motion of the particle. Now that question is similar what we have attempted in the last question. So what do you think the motion of the particle in this case will be? So first try it by yourself and think about it. We have a time of 60 seconds, so start. Alright, so we need to describe briefly, so we need to write detail about the motion of the particle. If you observe for the first 10 seconds, particle travels in a straight line. We can say that particle moves at constant speed of 10 meters per second for first 10 seconds. Alright, so that portion we have described from 0 till 10. It's a straight line, so it's a constant velocity, and after that it is a deceleration, right? So we can say that from t equals to 10 to t equals to 25, or we can say that for 15 seconds particle is decelerating. Alright, from t equals to 10 to t15, or we can say that for 15 seconds particle is decelerating, reaching a velocity of minus 10 meters per second. You can see on your graph. Alright, so that is your first part answer. We have described the motion of the particle in detail. After that, for part B, you need to focus on the question. There is no need to write down the solution. I will give you time for that. Find the deceleration of the particle, deceleration of P for the interval between T0, T10 to T25. From T10 to T25, what is the deceleration? By deceleration, it means that you need to find out the gradient of this line. Alright, so what is gradient? For part B, we need to find out deceleration. That means we need to find out acceleration. Acceleration on speed time graph is rise over run. If you observe the rise part, so rise part is this one, right? From 20 to minus 10, the rise part we have it's 30, and for the run part, for the horizontal, you can see that it's from 25 till 10. You have a run of 15. So the deceleration you have is 2 meters per second square. Alright, clear? After that, for part C, it says find the time when P is instantaneously at rest. Alright, instantaneously at rest means that the velocity is 0. From the graph you can observe that this point here is where the velocity is 0. Alright, so let me say that this point we have it's t. We have the gradient of this line here. We have the gradient of this line, and gradient of a line cannot be changed whether there are 2 points, 3 points, or 6 points. Gradient of a line remains same. So I am applying the same concept of gradient, but this time what is the rise we have? Rise is 20. What is the run we have? Run is this part, right? So it's t minus 10. Rise over run t minus 10, and the gradient of this line which we have find out is 2. Alright, so if you simplify to 1s are to 10s are, that will be 10 equals to t minus 10 leads to t equals to 20, and that is your answer. Alright, clear? After that, for part D, it says find the total distance traveled in the first 25 seconds. Now, if you are dealing on velocity time graph and it talks about find the distance, so keep in mind at your velocity time graph, distance is basically equals to area. We need to find out the area in this question. If you observe the first part, that means this one. Alright, if you observe this part, so that it is a rectangle. The area of this portion, it will be 10 into 20 gives the value of 200. So in the first 10 seconds, particle travels the distance of 200 plus after that. If you observe this portion so that it is a triangle. Right? Area of triangle we have it's 1/2 base into height. Base is what? The distance between these two. The value of t we have to find out it's 20. Alright, so 20 minus 10 it is 10, that is your base, and the height is 20. So when you simplify 5 times 20 is 100. So that area is from the time t 20 to t10 to t20, and this area is the area of yellow portion from 0 to 10. Alright, after that this area here, again you can observe that it is a triangle, and area of a triangle is 1/2 base into height. What is the base we have? From 25 to 20, base is 5 and height is 10. We are not taking minus 10. Minus 10 is only for the direction. The magnitude is 10 only. So 2 ones are 2, 2 5s are 10, 5 5s are 25. If you add all those values, so you got the answer 325, and that is the total distance traveled by the particle in this velocity time graph. Alright, I hope that it is clear to you. After that, the last part, which is very important, and that is why I have picked this example. The last, find the lines and the distance of P. Find the distance of P from its starting point after 25 seconds. In the last part, we need to find out displacement, not distance. We need to find out displacement. Now, when you talk about displacement, keep in mind that direction is important in displacement, right? The value for the distances we have find out will be same, and that values are it's 200. It will be 5 into 20, it's 100. Alright, and that value we had last part, it's 25. The values will be same, but now we need to focus on the direction. And what do you mean by that? If you observe that yellow portion area, it is above the curve, so it will be 200. If you observe green area curve, it is also above the curve, it will be positive 100. But if you observe that blue area, so it is below the curve, so this time for displacement part, keep in mind class, for displacement part, direction is very important. So now it will be minus 25 because it lies below the x-axis. So now you have an 300 minus 25 leads to 275. That is your displacement of the particle from t0 to t25. So the important point I need to highlight here that if you have displacement below the x-axis, you need to incorporate negative sign. But if you have a distance below the x-axis, there is no need to highlight negative sign. For displacement, sign or direction is important. For distance, it is not. Displacement, it is important. Distance, it is not important. Alright, so I hope that this example is clear to you, and now you have an idea how to solve velocity time graph, because we are going to solve this question, such type of question in our next class. Before proceeding further, I recommend you to write down the example in your lecture copy, and you have a time of 2 minutes to note it down. Alright, so start. Alright class, so I hope that it's clear to you, and now you have an idea how to solve velocity time graph and how to sketch the curve. I think it is quite enough for today's class, and for the next class what you need to do as a homework, you need to attempt example number 8. Similar to example number 7, example number 8 is also very important. So you need to understand the concept, and we are going to discuss such type of questions in our next class.